All right, we ready for this? All right, writing exponential functions. It's going to tie into what we did the other day. Do you guys remember this equation? Okay, this is what we did the other day. We did y. Oh my gosh, that marker is awful. Next. Nope, missed. Okay, we had y equals abx. Do you guys remember that? Yes, where a was the initial number or your y-intercept, right? Your b was your growth or your what? Or your decay. Now, what was the key about growth? Do you guys remember this? If it's growing, what is it? Nope. There's a magic number I told you. It had to be above some. It had to be greater than 1. What was decay? Less than 1. Okay, do you guys remember all that? And exponential growth looked like this. Exponential decay looked like this. Do you guys remember that now? Kind of, sort of, refresh. We're still going to be talking about the same thing. Okay, we're still going to be talking. I want to make sure the video's on. Yep. We're still going to be talking about the same thing, the exact same thing. We're still talking about exponential growth, exponential decay. The notes today should not be anything crazy because it's basically a carryover for what we did the other day. It's the exact same stuff. Okay, the exact same stuff. I'm just going to add a little bit to it. Okay, just add a little bit to it. So here we go. This is the information we have. Writing and solving exponential functions. We're just going to jump right into this. Okay, so here we go. Your favorite shoes are on sale at 30% off. Okay, now what's the question people always ask in math? When am I ever going to use this stuff, right? When am I ever going to use this? Okay, so I'm going to show you how to do this. Your favorite shoes are on sale 30% off. The original price was $74.99. What is the sales price of the shoe? And how would you typically figure this out? So how would you guys figure this out? If you go shopping with your parents and you're like, Mom, I know you guys do this because my kids do the same thing. Hey, Dad, will you buy me these shoes? They're 30% off. And here's what I tell my kids, especially as a math teacher. And Carly, if you know I'm not lying, okay? I tell them, I will buy the shoes for you if you can tell me how much it is. And they're like, it's funny the way they look at me, but it's 30% off. I'm like, okay, what is 30% off? And I make them do the math before I spend the money. And they're like, man, that's just mean. I was like, I don't care. Like, you're going to learn how to do this in real life. Like, how do you know you're getting a good deal? Like, how do you know that you're getting a good deal? Does everybody have their calculator? So here we go. Let's figure this out. I'm going to show you how to do 30% off. Okay, this is very easy. You can do this now, when you're out in real life. When I was growing up, the big thing was, you need to learn how to do this math because you're not going to have a calculator everywhere you go. Okay, well, now what do we have on our phones? Everybody has calculators. Okay, so now that argument is mute. So let's just learn how to use them. Fair? All right, so here we go. $74.99. I'm going to show you how to do this. What percentage off is this? 30%. What is 30% as a decimal? So do this. So times 0.3. Do that. Tell me what you get. Now what? 22.49. You guys with me on that? Now, here's how I always solve it. Now, you can go back and take the original price and subtract that. Or what I would do is just take the number that I just got and go minus $74.99. Minus $74.99. What'd you get? What? 52 what? 52.49. So basically the shoes are now $53. You just knocked off 30% of that there's your 30% off. So you basically just take that amount and subtract it, okay? That's all it is. Does that make sense? When you have a sales price, and people want to know this, okay, when you have a sales price, just take that percentage as a decimal. So if it's 70% off, multiply it times 0.7 and then subtract it from the price. And that's going to be what it is on sale. That's pretty easy. So my daughters have actually gotten really good at it. They've actually gotten good. If it's something's 20% off, they can find 20% off. Okay? If it's 30%, the way that I do it, here's how I do 30% off. Okay? As a math teacher. If something is, what is that close to? $75, right? You guys with me? 10% of that, what is 10%? 7.5. Right? You just move the decimal one time over, right? So 30% of that would be times 3. So I would, in my head, I'm like, okay, 21. I'm just going to call it $22 off. 30%. You just basically take 10%, multiply it times 3. Okay, and that's the way I always did it in my head. Okay, I still to this day will do it. If something's 20% off, I know to take it, multiply it, and double it. Okay. All right, so here we go. That's how you figure this out. We are gonna see that more often. Okay. So let's talk about exponential growth and decay. We already know how to do this. ABX. Now, the percentage growth and decay. This is where it's going to change a little bit. It says 1 plus R, okay? Or it says 1 minus R. You guys with me? So do me a favor, draw an arrow to the plus. The plus is going to be your growth. In other words, remember growth is above what number, guys? It's above 1. What is decay? Below 1. So my minus would be decay. Okay, so we're going to subtract a percentage. And I'm going to show you how this works in just a minute. As long as you kind of understand the main concept of that, it really should not be a problem. Everybody trust me on this? All right, so here we go. The school currently has 1,800 students and a 25% growth rate due to people moving into the school each year. This is like one of the problems that they have in like Prosper, okay, or Argyle and places like that. These places are just blowing up, okay? Schools are just growing. Okay, 1,800 students, and they grow by 25% each year. Okay, what is the initial amount? Okay, let's walk through this worksheet together. What's the initial amount? 1,800. Go ahead and put that down. Which, in other words, that's going to be my A, by the way. Remember that? ABX? My initial amount's going to be A. Now, what is our growth rate? 25%. Okay, so it's growing 25%. All right, so here we go. You guys ready for this? Please pay close attention because what I'm about to show you is very, very important, okay? Now, if you went back a slide, if we go back, well, let me go back a slide. It was 1 plus the rate. You guys with me? Now, what did we just say that the rate was? 25%, right? So what I'm going to do is I'm going to take this percentage and I'm going to write my equation. Y equals, what's my initial number? 1,800. And then it's growing. So I'm going to go 1 plus, what's 25% as a decimal? Nope, 0.25. And then I'm going to put an X up there. Basically, what I just did was I improved it from just a 1 to a 1. Now, can I just write this as 1.25? Is that above 1? Yes, it is. That would tell me, if I see the 0.25, please hear me on this. A 0.25 on the end means that it's growing by 25%. Yes? Okay. You can just add this together if you want. Another way to write this equation would have been this right here. 1,800 times 1.25 with the X. Isn't that above 1? By 0.25? Yes. It's now I just combined them. Either way works. There is no right or wrong way. There is no, now don't put minus, because what is 1 minus 0.25? But what is it? What's that? What's 1 minus 0.25? Think of a quarter. What's $1 minus a quarter? 0.75. Okay, but that's less than 1, isn't it? That means the town would be decreasing by 25% every year. That's not what we're doing. All right, so here we go. Predict the number of students that you have in 2 years. So here you go. You have your calculator? Where do you think the 2 is going to go? Where the X is. That's where you put your 2. Go. Use your calculator and find it. Cross multiply. Hey. If it works, but yeah, but here in a second I'm going to show you how to do a table. That's a lot of work though. Because I would rather you just put it in the equation. Yes. What'd you get? Yeah, I'd say. What'd you say in 2 years, guys? 2,800 and what? 13? Okay. Now, it's an estimate. Does that mean it's going to be exactly 2,813? No, it's growing by about 25%. That means some years are going to be higher than others, okay? Now, do me a favor. Go to y equals, and I want you to type this in exactly as you see it with the X. Type that in exactly as you see it with the X. Go to y equals 1,800, and then I want you to go parentheses, 1.25, and then put the X on the outside. Remember, the X is the button next to the green one. Yes? Once you're done, you don't have to hit graph. Hit second in graph, and that way you get your table. Hit second in graph, and you get your table. Did you get it? You see where it says 0 is 1,800, and then after year one, it went up. It goes up every year. So what would it be in 5 years? 5,493. 25% increase every single year. Okay. A story about Prosper. Can I just throw this out there? When I was teaching at Whitesboro, they built Prosper High School, like the original one, like where it is now, like massive. Prosper High School was a 3A high school, and they built this massive high school. I'm like, why are they building this huge high school? But they knew what was coming. They knew that growth was coming. Now they just opened their 4th 6A high school. So like, I'm talking about the growth. If you guys go up there, every time you go up there, there's something under construction. Dallas North Tollway is being under construction, right? Like, it's just stupid. Okay, everything's under construction up there. Okay, growth. All right, is everybody good? Everybody sort of understand this? Growth means you add. Decay means you what? Subtract it. Cool, let's go on. Ed bought a new Mustang for $20,000. Does this sound like something you might actually do in real life? No, it's not new for $20,000. Let's say you got a used car for $20,000, okay? He bought a Ford Mustang, $20,000. Mustangs, what's that word? What does depreciate mean? It goes down in value. Cars usually go down in value. The more you drive it, the less it's going to be worth. Okay? That's what cars do. Mustangs depreciate at a rate of what? 0.22. So here we go. What's the initial value? 20,000. Okay? What is our growth/decay rate? Minus, we're going down 22%. We're going down 22%. Or I'm going to call it, let's call it negative, or 0.22. Yes, negative 0.22, which is 22%. I just made it a decimal. Okay, go ahead and write your equation. Is this one going to be 1 plus, or is it going to be 1 minus? 1 minus. So if you end up with 1.22 in your parentheses, you did it wrong. Because what is 1 minus 0.22? You could actually just write 1 minus 0.22 and it'll do it for you. Okay? And then I want you to tell me what the car is going to be worth in 6 years. Okay, hold on. Here's your equation. Y equals 20,000, right? 1 minus 0.22 with the x, correct? And if they want that, you can can't you put that into your y equals and get your table? Yes? Everybody focus for me. Can you put that in your table and get, yes? What would it be if this was a 6? What is it? 4,500 and what? 504? There you go. $4,504. After 6 years, your $20,000 car is worth $4,000. That's actually pretty realistic, believe it or not. Okay? Some people are like, man, I want to get a brand new car. Please say, I want to buy a new truck. Okay? I really want to buy a new truck. New trucks right now are like the ones I want to get an F-250. These things are like $70,000. I keep looking at them going, I'm a teacher. Like, what do I need an F-250 for? Okay? But I like them because they're four-wheel drives and they can tow about anything. Okay? But here's the deal, and this is my point. If I buy a $70,000 vehicle, as soon as can I give you a hint? If you buy a brand new vehicle, as soon as you drive it off the lot, what is that brand new vehicle? Well, say it. Who said it? It's used. You now have a used car. As soon as you drive it off the lot, it is. You could turn around and the next day you're like, you know what? I'm gonna trade it in. You are now probably going to get a lot less than what you just paid for it because you just depreciated the car because you went from a new car to a used car. Okay, that's how it works in real life. Unless you plan on keeping it for a long time. Okay, that's just the way that it works. That's 100% the way that buying cars works. Okay, car dealerships are going to make their money on you. I promise. Okay, 100% they're going to make their money. All right, everybody good? The inner right pad your teacher, I don't know what the heck that is. Okay. The pad your teacher is using this year has become famous and is now considered a collector's item. As a result, it's going to appreciate at 15% per year. The school paid $150 for this thing. What's it going to be worth in 10 years? Okay, here's what I want you to do. With your neighbor, I want you to solve through these questions. I'm going to pause the video. All right, ready? Go. All right, so the question we had, I just unpaused the video so we could have it. How do we know what goes in the exponent? Okay, so here's a couple different ways you can do this. We'll talk about that in a minute. What's the initial value? 150. What's the decay, or is it decay or is it growth? Growth. We're going up 15%. I like putting plus 15, so that way when I write the equation, I know it's 1 plus 15. Okay? The equation, y equals 150, parentheses, 1 plus 0.15 with the x. Now, here's the question. If you want to see the table, with all the values, you have to put the x. If you don't care about the table and you just want to find out what it is in 10 years, instead of putting x, I could just put a 10 there in the regular calculator, and it'll solve it for me. Does that make sense? Does that make more sense? Okay. The x is if you want to see all the values. Okay? But if I just want year number 10, you just put a 10 there. Does that make sense? Okay, how much is it worth in 10 years? 600 and what? Okay, at what point does it get above $10,000? Does anybody have the table? 31 years? 31 years. So you can go back to this and change that to 31, and I bet it's over 10,000. Okay. Everybody good? Everybody understand how that's working now? 1 to 5, how do you feel on this? See a lot of 4s and 5s. Good? You liking this? A lot of people like it because it's talking money and it's real life. Yes? You like this. You like when stuff appreciates. All right, here we go. A rubber ball bounces half the height from what it should have dropped from an original height of 200 centimeters. Okay? Let's see if you can figure this out with your neighbor. Go. All right, here we go. What's the initial value, guys? How high was the ball? 200. Okay, what was the decay rate? Negative 0.5, because they're dropping it. It's getting half the height. So on the second bounce, after 200, the second bounce, it should do what? 100, and then 50, and then so on, right? Because think about it. If you drop a ball, it's going to bounce, and it's going to bounce, and eventually the ball is going to stop bouncing. Yes? It's decaying. Okay? I don't think I've ever seen a ball hit and then bounce higher than when it was dropped, unless you actually forcibly push it down. If you just drop it, it's not possible. Okay? All right, here we go. Write an equation. Y equals 200. 1 what? Plus or minus? Minus 0.5. So it's half. To what? Well, x or 4. So how high is it after 4 bounces? 12.5 centimeters. Thank you for labeling it. Thank you for labeling centimeters. Okay, that's important. Thank you for doing that. A lot of people would just put 12.5. So you guys saying centimeters, that's really, really good. Okay, are we good? All right, we're getting somewhere now. All right, do you guys understand? Cool, let's answer some questions. Does the equation 11 times 1.11 to the t power model exponential growth or exponential decay? Okay, why would you say growth? Because this is greater than 1. Would you agree? So we say exponential growth. So I'm going to go one step further. What was my initial number? You need to be able to identify this. What's the initial number in that equation? 11. Let me ask you this. What is the growth factor? What percentage is my growth factor on this problem? Huh? Nope. 11 what? No, we need to know how to do this. Okay, this is what I'm telling you. Okay, because they're going to ask you questions like this on the test. Okay, my initial number, my A is 11. Now, we obviously know it's in there somewhere. Agreed? We know it's in there somewhere. You guys have told me it's already growth because it's above 1, right? How far above 1 is it? 0.11, right? Everybody, yes, is everybody with me? Growth is easy. Growth is very, very, very simple. Think about it. If it's growth, you're going to have 1, and then you're going to have a decimal on the end, and it's going to be 0.11. So what is 0.11 as a decimal, or as a percentage? It's 11%. We'll go back the other way. Remember, if it was 25%, did we make it 0.25? Yeah, I heard some. Oh, yeah. We did, didn't we? If it was 25% earlier in the notes, we made it 0.25. So what makes it different from 0.11? 0.11 is 11%. The decimal moves twice either way. Okay, does that make sense? So what would this one be? Forget about this problem. Let's say I have 250 and then I go 1.6 with an x. What is that? Huh? Nope. What percentage is that increase? 0.6 what? We got to move it twice. Thank you. Say that louder. 60%. This one's a 60% increase. You always move the decimal. How many times? We take the 1 off. Take the 1 off because remember, the 1 is the growth, right? Take the 1 off and you have 0.6 and just move the decimal twice. 60. Okay, it's always twice. It's how many times do you move the decimal? Twice. So what if I did this? 1.352. What percentage is that increase? 35.2%. Does everybody understand now? It's like, okay, yes? Good. I want you to understand that because I want you to be able to get that if we get a test, okay? What if it was this? One more. What number do we take off, by the way? What whole number do we take off? 1, okay? So stick with me on this. Hold on. What number did I just tell you to take out of there? What whole number? 1. So if you take a whole number of a 1 out of there, what do I have left? No. Take the 1 out. Hold on. Wouldn't this be the same as this? Would you guys agree? Is everybody with me? Okay. So just stick with me. I'm kind of messing with your brain a little bit because I think this class can handle it. Okay. Wouldn't this be 1 plus 1? Yes. So if I take that 1 out, what is 1 as a decimal if I move it twice? No. Move the decimal twice. What does it become? 100%. Basically, I just added another whole number to it. Okay. Move the decimal twice. If it's 1, it stays as 1.0, doesn't it? Isn't 1.0 the same as 1? Okay. We're going to work on this. We're going to work on it. Okay. All right. Let's do the last one. 0.8. Is it exponential growth or is it exponential decay? Okay, it's decay. What's the decay rate? Nope. The decay is a little different. What? No, I'm still waiting on it. Stick with me. I'm almost done. Stick with me. I know you're off in la la land there for a second. Nope. If we can figure it out. How do we get to 0.8 in exponential decay? 0.2, which is what? Now, what percentage is 0.2? 20%. We just dropped 20%. Thank you for finding that. How do you get to 0.8? You do this, don't you? Hold on, think about it. 27, wouldn't this be 1 minus 0.2? Wouldn't that get me 0.8? Because it's less than 1. We just lost 20%, didn't we? Is everybody sticking with me on this? So how do you find this? Can I show it to you? Get your calculator. What's the number in the parentheses? Type 0.8. Just hit 0.8. Minus 1. What'd you get? Just for the heck of it. Times 100. 20%. Because we moved the decimal twice, right? We just multiplied times 100 is how we got the percentage. Okay? You can use that. Hey, you can use that trick for the other side too. Think about it. What if it's 1.7? Okay? Do me a favor. Hit 1.7 and subtract 1 from it again. What'd you get? 70%. That's 70% growth. Okay? Whatever number you have in the middle, you can go whatever number that is minus 1, and it'll give you what your decimal is. Everybody with me on this? So what would this one be? I'm just making something up at this point. 16 parentheses, let's go 0.38 to the x power. What rate did that drop? Find it for me. Yeah, I want the percentage. I don't want the decimal. Give me the percent. 62%. Because if you go 0.38 minus 1, here's what you should have. 0.62. Yes? Which is 62%. Basically, what they just did was they took that 62% and wrote it like this. Isn't that what I just taught you a minute ago? I just showed you how to do it backwards. Take the number and subtract the 1. Everybody's nodding. I kind of see you. Everybody can find that, right? Everybody good? Can I do one more? Okay, I'm going to have you write your answer down on just somewhere, like a little piece of paper, just maybe on the side of your notes. Just put your answer somewhere because I'm going to have everybody say it at one time, okay? Give me the percentage of this one right here. 0.08. Write it down. Don't yell it out. Write it down, please. Put it as a percentage. Put it as a percentage. I want to see it. I'm walking around. I'm checking you. Oh, don't cheat. Don't look at hers. Hey, 1. That number minus 1. That number minus 1. Show it to me. Where's yours? Take that number. Subtract 1. Just in your calculator. Okay? It's going to give you a number. It's going to give you a decimal. Did you find it? Yeah. Where's it at? Show it to me. Show it. No. Calculate. Write it down. Just somewhere. Perfect. Thank you. What'd you get? 92% decay. Okay, everybody kind of seeing this now? Everybody's good? All right, I'm going to give you guys a little bit of a break. We're going to practice this quite a bit today, okay? All right, good job today, and we will go on from there. All right. Click like, subscribe. Hey, share it on your socials. Share it with your friends.